Today, I'm going to show you how to project materials onto steep slopes. Let's go! So we're in the middle of a series of videos on making terrain shaders. So far in the series, I've shown the basics of making layered terrain, and I've showed several ways of making terrain faster to render. If you'd like to take a look at the rest of the videos in the series, I've linked the whole playlist down in the description. Today, we're going to focus on projecting materials onto steep slopes. One of the many challenges with terrain is that UV coordinates are typically projected from the top down. This means that anytime you have a steep slope like this, the materials on the slope look stretched because the coordinates are getting warped. Often, you can get away with this just fine if your terrain doesn't have steep slopes, but if your map has cliffs like this, you're going to need to come up with a way to deal with these stretching artifacts. Now, one way to handle this is just to cover it up. If you make a bunch of rock cliff meshes, you can just shove them into the terrain wherever you've got a cliff and cover that part that looks stretched. This may sound like cheating, but I think you'd be surprised by how many games do this. But if you want to fix it with a method that's built into the shader, you can create a coordinate projection that works better with steep slopes. And that's what we're going to do today. First, I'll show you how to do this in Unity, and then we'll switch over to Unreal in a minute, and I'll show you how to do it there as well. Now, the first thing that I want to mention right here while we're jumping in is I have this example created that really stresses it because we're making about as steep a slope as we can possibly make with terrain. But if all you do is smooth out your slope just a little bit, like I've done over here, it solves maybe 85 to 90% of the problem. So all I did is smooth out my slope here, and I can do that just like this. If we switch this to smooth height, and I just kind of smooth it just a little bit, you can see that, just a tiny bit of smoothing goes a really long way to solving the problem. And so before you go through the trouble of changing your shader to get rid of this stretching, you may want to look at your terrain and see if you can just fix the problem by smoothing it out just a little bit. The technique that I'm going to show you today does add cost to your terrain shader. And so you have to decide, is it worth it to make my shader a little bit more expensive? Or can I solve this just by, covering it up with some cliff rocks or smoothing out the terrain a little bit? All right, well, let's go ahead and jump in here and create a terrain layer that is specific for doing a better job at projection. I'm just going to right click in here and pick, actually, you know what? Let's start with our simple layer. I'm going to clone the simple layer that we made a couple of episodes ago. I'll just copy and paste this. And we're going to call this one triplanar layer. And we'll open it up and get started. Okay, so here's the shader that we're starting with. And you can see that we're bringing in our color texture and our normal map texture. Then we're getting the texture coordinates from them. And then we're sampling those two textures. And our normal map texture is a special one that's been packed. And I described this packing in a previous episode, so I'm not going to go over it here, but you can see that we're unpacking the normal and also unpacking the color, also unpacking the occlusion and height, and then passing those values out. So go ahead and clone your simple layer that you created in the previous episode, and we're just going to change this one so that it does something called triplanar projection. And the nice thing about this technique is Unity has a node built right in called triplanar. And what this does is it samples the texture 3 times. The first time is projected from the top, the second time is projected from the front, and the third time is projected from the side. So that's why it's called triplanar, because it's projecting from 3 different planes. And so instead of sampling the texture with a texture sample 2D, we're going to sample the texture with a triplanar node. So I can just take the same texture that I'm sampling here and pass it into my triplanar node instead. Now there are a couple of things that I need to know about what the triplanar is doing. First of all, the smoothness of the blend is covered by this blend value here. And I don't want to have a really large blend around the corners. And so I'm going to set this to something fairly high, like 64. So there's kind of a sharp cutoff between these three different projections. And then the other thing that I need to do is set up my position. And in order to do that, you can see that by default, it's using the world space position to project my textures. And the reason that it's able to fix the stretching is because normal terrain is just projected from the top. But this one is projected from the top, front, and side. And so it's able to look correct even on steep cliffs. So we're just going to bring in our position node. And we can take this position value that's in world space and divide it by the number of times that we're tiling the texture. And in my case, I happen to know that my texture is tiling every 2 meters. And so if I divide this by 2, that's going to mean that it's projecting the texture every 2 meters. And so now I can just pass this right into position, and that's going to give me the right texture coordinates. Okay, and so now all I need to do is pass the results of my triplanar node out in the place of the previous sampler. And the sampler is taking the alpha channel, and so I need to split out the alpha channel. I've got the smoothness stored in the alpha channel, and if I just pass out my smoothness like that, now I'm projecting the color of my texture using triplanar. And I can go ahead and delete this sampler now, and let's save it. And now let's set up our shader to actually use this new subgraph that we're creating. So here's the shader that's applied to our terrain, the one that we created in a previous episode. And you can see that I have 4 terrain layers over here. Simple, simple. This third layer is using the tile breakup technique that we talked about last week. And then my 4th layer is just using simple. And these are projected from the top down. And you can see here I'm doing height-based blending, and then using this pre-multiply layer node here to blend my layers together. And then I'm just adding the results and then passing them out at the end. So this is a fairly simple terrain shader. Not a whole lot going on here. What I'm going to do is replace this first layer with the subgraph that we just created. So I'll drag and drop my triplanar layer into my terrain shader. And then I'm going to hook up my sampler state and then hook up my material going out. And let's save this and take a look at the results that we get on our terrain. Okay, now you can see that my stretching is reduced. My color is being projected using triplanar, but my normals are not. And so they're still stretching going on here. And so I need to go back to my shader and finish working on it. So here's my triplanar layer. You can see I've created the color using triplanar, and now I just need to create the normals using triplanar as well. So I can just take this triplanar node and copy and paste it. And we're going to bring it down here. I'm going to plug in the sampler, and I'm going to plug in the coordinates that I calculated here. Oh, that's already connected. And so now I just need to split out the results of this triplanar. And we need to take the red and the green channels. Those are going to become the normal. And I'll plug those into my vector 2. And then we're going to take the blue channel, and that's the occlusion. and I'll pass it out in these two spots here. And then the alpha channel is the height, and I'm going to pass that out as well. And so now I'm using triplanar instead of this projection here, and I can just move my triplanar node into place. And then the last thing that I need to do is make sure that I'm bringing in the right texture. So I'm going to connect up my normal map texture to my triplanar node there. Now we can save it, and we'll switch over to our scene. And now you can see that I'm correctly projecting this material onto the terrain. So even though I've got this really steep slope here, the material is still projecting correctly. And if I alter my terrain just a little bit, let's smooth it out like I was doing before. We'll just take this smooth height here. You can see that no matter how steep or smooth the terrain is, that projection is always going to work correctly without any stretching. So I'm able to use my triplanar projection node to sample my material textures multiple times and then project them from the top, front, and sides so that it gets rid of that stretching that I was getting earlier. Now, like I said, this is going to be a little bit more expensive. In my simple terrain shader, I'm only sampling the texture. I'm only sampling two textures, one for color and smoothness, and one for normal and occlusion. But in my triplanar layer, each of these triplanar nodes is actually sampling the texture 3 times. And so I'm doing 6 texture samples in this layer instead of 2. And that means you probably, if you need this technique, you probably only want to do it in one layer, in the layer that you're specifically going to be using on cliffs, and not just kind of go and apply it to all the layers just because you can, because it'll make your terrain a lot more expensive than it needs to be. Alright, so that's triplanar projection on terrain. It's pretty simple. Let's go ahead and switch over to Unreal, and I'll show you how to do it in that engine as well. Alright, here we are in Unreal, and just like we were getting in Unity a minute ago, you can see that I've kind of got this steep slope going on here on my landscape in Unreal, and I'm getting this stretching happening. And so what we're going to do today is I'm going to show you an easy way of fixing this stretching so that we can make our terrain, I don't know, look a little bit more realistic on the cliffs and not have this warping happening. So let's take a look at our landscape material here really quickly. I've got the simple layer material functions that I created, and then here is the tile break material function that we created last week. So we've got these 4 layers, and they're being blended together using height blending. And then I split out the material attributes and pass them out to the root node there. So what we're going to do today is replace this simple layer node here, this material function that's projecting our dirt onto that cliff. And we're going to make a brand new material function that does a better job of handling steep slopes so that we get rid of that stretching. Okay, so we're going to come down here to our content drawer, and I'm going to right click. Actually, let's just duplicate our simple layer material function here. I'll copy and paste that, and we'll rename this. And I'm just going to call it triplanar layer. And we'll open this up, and I'll just take this from where we had it before and convert it to our new triplanar projection. What we're going to be doing today is projecting from the top, the side, and the front. And Unreal has a really nice, elegant way of doing this that doesn't cost very much. In Unity, our triplanar node is sampling 3 times from the top, the front, and the side. But what we're going to do in Unreal is, instead of sampling our texture 3 times, we're actually going to blend the coordinate system. And by what I mean by that is right now our coordinate system, we're just projecting in absolute world position. But instead, what we're going to do is project those coordinates from the top, front, and sides, and then blend them using dithering. So let's create the node that does that here really quickly. I'm just going to do a search for, yeah, okay, so there are a whole bunch of new nodes that come with Unreal that start with coordinate basis. You can see that we can do cell bomb projections, capsule, biplanar. So there's a bunch of different projections that we can do. And the one that we want to do is called triplanar dithered. So I'm going to drop this node into our shader here and just talk about it for a minute. So the result of this node is UV coordinates. And we're going to use these UV coordinates to sample the textures that our terrain is using. So let's just go ahead and plug in our UVs. You can see here we are, before we were just projecting from the top down. You can see we're using the X and Y coordinates, which is a top projection. But what we're going to do instead is use the UVs coming out of this coordinate basis triplanar dithered. And I'm just going to plug my UVs in for both my normal, or for my color and roughness, and also my normal occlusion and height. So this is providing my UV coordinates now. And what it does is for faces, for areas on the terrain or whatever mesh that are facing up, it does a top projection. If it's facing to the side, it does a side projection. And if it's facing to the front, it does a front projection. And it blends between these three different projections using dithering. So we only actually have to sample each of our textures one time, and the coordinates that we're using to sample them are dithered. So it's a really good way of saving on performance. Okay, and then coming over here, this spot right here that says coordinate repeat, we need to pass in a value here that controls the coordinates. So by default, our multiplier value is 0.01. And what I'm going to do is give it a value of 0.005. And that's going to make our projection just a little bit larger. So I'm going to pass that value in. And then we're all done except for the last thing that we need to do. Oh, there are actually two more things that we need to do. We need to set our samplers to calculate the MIP level explicitly. So I'm going to come over here and pick the MIP value mode and drop this down and pick derivative. And what that means is it's going to expose these two new input ports called DDX and DDY, which allow me to give it some explicit derivatives or how it decides which MIP level to sample of the texture. And so this node here, the coordinate basis triplanar, actually calculates those values for us. You can see this DXY output port here. And what we need to do is bring this out and give ourselves a break float 2 node. And we'll just pass our DXY into that. And it's going to split out the red and the green channels. And we need that for our DDX and our DDY. So I'm just going to connect that up to both our color sampler and our normal map sampler. That's going to give us our derivatives. That's going to help us to calculate the correct MIP levels. Okay, and then the last thing that I need to do is correctly transform our normal. I'm deriving our normal here from the X and the Y component in our texture. We're multiplying by 2, subtracting 1, and then appending 0.5. And the last thing that I need to do over here on the end is add a node that will correctly transform our normals. Because right now the normals are projected 3 different ways. And so I'm going to add an MF tangent normal orient world. And I'm going to plug my normal into this. This TSN here means tangent space normal. So I'm going to plug my normal into that. And then in order to get the transform basis, I can come back over here to my coordinate basis triplanar and grab the tangent and plug it in, and grab the bitangent and plug it in, and also the rotation and plug it in. And now this is going to give me a correctly transformed normal. And I can take this and bring the tangent space normal out and plug that into the set material attributes and also the output normal. Okay, so let's just kind of step back here and review what we've done. So we took our top-down projection, which we were doing with our absolute world position node, and we replaced it with a coordinate basis triplanar dither node, which is projecting from the top, front, and side, and then dither blending the result. And we took the UV coordinates coming out of there and passed it into our color sampler and our normal sampler. We converted our samplers to using derivative gradients, and we passed in the correct derivatives. And then at the end here, we transformed our normal correctly using the MF tangent normal orient world. All right, so if we save this, now we can switch over to our terrain material, and instead of our simple layer, we can drop in our triplanar layer and connect it up instead. So I'm going to connect up our color, our normal, and our scale, although we're not using the scale currently. And I'm going to connect up our material here. And this is our third layer, so I'm going to connect it up right there. I'm going to connect up our height. And now we can get rid of this node that we're no longer using and move our triplanar node into place and hit save. So now, assuming that we did everything right, we can switch back over to our terrain. And yeah, now you can see that we've got our projection working correctly. So down here on the bottom, we're projecting from the top down. You can see that the coordinates are working great there. And then around the edge, we do a dither blend between that top projection and our front and side projection here. And we're no longer getting any stretching like we did before. So pretty cool. In Unreal, we're able to do that with just a single sample per texture, because we can dither blend the coordinates instead of having to sample the texture 3 times and then blend the results of the samples. So pretty cool. You can get rid of stretching on your terrain using this nice coordinate basis triplanar dither node. And you can do something similar in Unity as well. So there you have it. We've created a new layer material function here for doing triplanar projection. You know, last week we created this tile breakup node. So if your texture tiling is ugly, you can use that technique. And then previously we created several other materials as well. So if you haven't seen the other videos in the series, be sure to go back and watch the ones that I've created before. Anyway, that about does it for today. I hope you enjoyed the tutorial. If you have any questions or comments about these techniques, post them down below and I'll do my best to answer those. Thank you so much for watching, you guys, and have a great week.